Hi, good day, students. Yeah, this is Alpha Tutors, and this afternoon I'm here to explain Boyle's law. I want to look at the calculations on Boyle's law. Now, I will just quickly brief little things about Boyle's law. Under gas law, we have different laws that is talking about gas law. We have the Boyle's law, the Charles law, the Graham's, the general gas, the uh, Avogadro's law, and so on and so forth like that. And the that is partial law of pressure. So this afternoon, I want to look at Boyle's law. Now, what is Boyle's law? Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure, provided that the temperature is kept constant. I repeat, the volume of a given mass of a gas is inversely proportional to its pressure, provided that what the temperature is kept constant. That is how we have the mathematical expression of Boyle's law. Mathematical expression of Boyle's law is given as our volume is inversely very inversely as 1 over P. Do you understand that? So we have this also to be PV equals to K, introducing the constant K here. So therefore, we now divide our Boyle's law is P1 V1 equals to the P2 V2. Now, where our K remain our constant there, do not forget that. Our P is the pressure, our V is the volume. While P1 is representing the initial pressure and our V1 is representing the initial volume, P2 is our final pressure and our V2 is our final volume. Now, let's look at these few examples on Boyle's law. Boyle's law. Let's look at these few examples on Boyle's law. Now, they say the question number 1 here says 150 centimeter cube of a gas has a pressure of 450 milliliter per mercury. What will be its volume if the pressure is increased to 625 millimeter per mercury, assuming there is no change in temperature? Like I always tell my students, bring out your parameters first. Our parameters for this, is a Boyle's law, it's another Boyle's law. Now, our centimeter cube, 150 centimeter cube is a very well V1. The first volume there is 150 centimeter cube, comma. Now, our P1 there will be the first pressure given to us. P is going to be 450 millimeter per mercury. Then what will be the volume? That's what we are looking for, our final volume. So we are looking for V2, which we don't know. When the pressure, our P2, is now being increased to 625 millimeter per mercury. I believe we are together, guys. Now, moving on. Since we bring out our parameters here, we just need to apply this, input this parameter into the formula, the Boyle's law formula, which says P1 V1 is equals to P2 V2. Are we together? Now from there, we are going for our V2. Making V2 is something of formula here. This chemistry, we don't need to be doing divide both side by. So making V2 is a formula here, divide both side by P2, which is the one disturbing this one. So therefore our V2 will be equals to P1 V1 over P2. Now let's input the values there to get our V2. Now we have a P1 is 450 milliliter per mercury, 450 multiplied by our V1 is 150 over P2 is 625. So our V2 will be equals to, let's calculate our, let's look at our calculation here. 450 multiplied by our 450 multiplied by 150. 450 multiplied by 150, we have 67,500. So we have 67,500 over 625. So if we divide 67,500 divided by 625, So we have 108. It gives us exactly 108. Now, definitely, our V2 will be 108. But one thing I will tell students is don't forget your parameters. Your parameter is very, very necessary, and your units. You understand that? Your units in your parameters are necessary. We are calculating for volume, and the first volume is given in centimeter cube. So definitely, our answer must carry centimeter cube. 108 centimeter cube. Is this clear? I hope that is clear. Let's do the second question. Now, we have the second question here. Let's look at the parameters. They say a gas at volume B0 in a container at pressure P0 is compressed to 1/5 of its volume. What will be its volume if it maintains its original temperature? What will be its volume if it maintains its original temperature? A gas at volume, the first volume there is given to us. So we know our V1. Our V1 will be V0. Are we together? At the container pressure, in the container at pressure what? So our P1 is what? P0. What will be its pressure? What are we looking for here? What will be its pressure? We are looking for the P2 as well here as well. P2 is not known, comma. When its volume is, when it's compressed to 1/5 of its volume, 1/5 of its volume will be, that definitely our V2 will be 1/5 is 1/5 of V0. 1/5 of its volume. You know the initial volume is V0. So 1/5 of the volume is telling us about the 1/5 of the initial volume. That's 1/5 of that volume. Now let's apply the formula for Boyles law to this. Easy. We have P1 V1 equals to P2 V2 is our Boyles law. So making P2 solve the formula, divide that by V2. So therefore our P2 will be equals to, that will be P1 V1 over V2. Definitely we are going to have P2. Now substituting the parameters here, we have P2 equals to, that will now be, our P1 is P0 multiplied by our V1 which is V0 over V2 which is going to be 1/5 V0. Are we together now? Are we together here? From here we can say this cancel this. Just our normal arithmetic. You can use this to cancel it since they are having the same parameters. That cancel that. So definitely we are left with P2 should be equals to P0 over 1/5, which you can easily write as P0 divided by 1/5, which will give us as P0 multiply. Your division will change to multiplication, and that will make this 1/5 to change. Your numerator become denominator, denominator become numerator. So we are going to have 5/1. Definitely we have our answer to be 5P0. Do we understand? Like somebody will ask me, are we going to put units here or not? I will not put units here because in the question I don't have a unit given to me for my pressure and my volume. So I will leave it that way. Thank you. God bless you.